Hello, Dr. Gilmet here, and I just wanted to start talking about hypothesis testing for two independent samples. And today we're going to be using Excel to do it. I've transitioned over to Excel and teaching my classes. It seems like a good life skill. So here we go. Earth 2 is the title of the problem. Cisco Ramon encounters Death Storm on Earth 2 during several fights. Looking over the power readings, he wonders if Death Storm has more power than Firestorm on Earth 1. So this is a reference to the crossover episodes with Flash in Season 2. And so below are the data from both. That should be R. The data from both. So here are Death Storm's power ratings in like megajoules or something like that. Here are Firestorm's ratings right here. And so basically what I did was I went ahead and put them in my Excel spreadsheet so I could do a few things with them, right? And so when we're doing a hypothesis test, the first thing we have to do is actually write the hypotheses. And so when you're having two samples, you're basically trying to find the difference, the average difference between the two of them. And so your null hypothesis, H naught, is going to be mu, the mean of the first one, minus mu, the mean of the second one, is typically equal to 0. There might be occasions where you put some sort of shift in there, but almost always it's equal to 0, right? So here I have Death Storm first and Firestorm second, so Death Storm versus Firestorm. And of course that's going to be 0. And then for my alternative hypothesis, he's wondering if Death Storm has more power. So I've put in the greater than sign to reflect that, right? So the more power indicates the greater than, and Death Storm is first and Firestorm was second in the problem, so I've just organized them that way. All right, so next what we need to do is, are the conditions for inference met? Were they randomly selected? It doesn't say randomly selected, but it is Cisco Ramon, so we might assume that. Independent, because Death Storm is on Earth 2 and Firestorm is on Earth 1, I'm going to say that independence is definitely a given. These are two different individuals from two different dimensions, two different Earths, so those are definitely going to be independent. Less than 10% of the population. As we look here, I've got 8 power readings, so that means that Death Storm would have to have at least 80 fights. Firestorm would be the same thing, and so that seems plausible, that seems reasonable. And then for sample size, we're going to look at the means and the histograms. And for that, I'm going to switch back over to my Excel spreadsheet. So I looked at here, and I noticed I had 221 was kind of my largest value, and 186 was my lowest value. Over here, I noticed 188 was my lowest value, and 206 was my highest value. So I just kind of picked bin sizes from 180 to 210 to sort of grab all of this. And I went ahead and did data analysis. I do have a video on how to install the data analysis tool, and there is a histogram function, and I used that. And so the input for like Death Storm would have been here like this. The bin range, that was why I had to have these in here. They do have labels, and I went ahead and output the data here. With a chart output, but I'm not going to do the chart output. And you click OK, it says it's going to overwrite the data. I click on OK, and there it is, right? So the chart for Death Storm looks like this. It actually looks like it's skewed to the left a little bit, and this could be because of the bin size that I chose, or it could just be because I only have 8 values. So I could do one of two things. I could play around with the bin sizes and see if I can make it look normal, or I can actually look at the mean or average function for the 8 values and the median for all 8 values. And typically if they're close together, and these are, if they're close together, that indicates a certain amount of symmetry. If the mean and the median are close together, that means you don't have too much skew or outliers or anything like that. There is a balancing point near the middle of the data, right? So I did the same thing for Firestorm, right? I selected the data, I created the chart. The chart for Firestorm looks like this. this actually is looking pretty good. This is kind of normal-ish looking, right? You could say it was skewed to the left a little bit, but again, that could be bin sizes. I do only have 8 values. So what I'm going to do is, instead of typing in the formulas, I'm just going to go ahead and drag the formulas over, and I can see that 197.5 and 198 are very close together. So again, this would indicate that the assumption for sample size, them being normal, symmetric, unimodal, is going to work. And so that makes us happy. So the conditions for inference are met here. Alright, so now we're ready to do the calculations. So I'm going to provide the calculations, and I need the sample mean difference, right? For my t-stat, I need the sample mean difference. And also for my t-stat, I need my standard error. So I need the sample mean difference. I'm going to go to my Excel spreadsheet, and basically it is the sample mean of the first minus the sample mean of the second. So death storm minus firestorm, we get 9.48, right? Next, for the standard error, you've got the standard deviation squared, right? Standard deviation squared. And so I actually have the standard deviations calculated and their sample sizes right here. So now I can go ahead and use equals square root of, right? I'm just going off this formula right here, the square root of the first standard deviation squared divided by n, right? So the first standard deviation squared divided by n plus the second standard deviation squared. And again, I'm just going off this formula right here, the second standard deviation squared divided by its n, right? Divided by its sample size. And I close it up, and I get 5, okay? So I've got those two things. And now for my t-score, the numerator is this, right, which is this right here, and the denominator is the standard error. Now, I've actually simplified this a little bit, okay? If we look, this should actually be this, right? I'm going to grab this guy right here, copy, and paste it down here, right? Like this. This is actually the full thing. But remember, mu minus mu is actually equal to 0 from our null hypothesis. And if you subtract 0, you don't change the value. So a lot of times you'll see it simplified like this. So I just need the sample mean difference divided by the standard error, and that's going to give me my t statistic, right? My test statistic. And so the t-score is going to be equal to my mean difference divided by my standard error. And I get 1.885. All right. Now the next thing that I need is I need my degree of freedom. Now, if the standard deviations of the variances are equal, you would use this formula right here. Sample size 1 plus sample size 2 minus 2, right? You've got 2 sample sizes, so you need to subtract by 2. Oh, there you go. If the standard deviations or variances are unequal, if they're very different, then you take n of the smallest sample size, and you subtract it by 1. Now, please note, there is actually a complex formula for calculating the exact degrees of freedom when you have 2 samples. But I am not using it here. I am using the rule of thumb conservative estimates so that you maybe are overestimating the p-value for rejection purposes, okay? So this is an excellent rule of thumb if the standard deviations are equal. This is an excellent rule of thumb if the standard deviations are not equal. And if you look over here, you've got 12 and 7.2. And you're like, oh, those don't seem that like big a difference, right? But that's actually a pretty big difference, because if you actually went ahead and squared these values, if you took these values, right? If you took 12 and you squared it, you would get 144. And if you took 7 and squared it, you would get 49. And so this is almost 3 times bigger in terms of variance. And so these are pretty different. All right, so what we're going to do is I'm going to use the degree of freedom of the smallest sample size. Well, they're both the same, right? So I'm going to take that sample minus 1, and I'm going to have a standard deviation of 7. And now I'm ready to calculate the p-value, which is really what I want. Now this is a t distribution, so you're going to use t dot dist distribution, right? There it is. And this is a right tail distribution, right? It's a right tail distribution because we're doing greater than. So we're going to do the right tail distribution. And now the x, right? This is my t-score or my t-stat. And then my degree of freedom is right here, right? And so you've got those values right there, and you hit enter, and you get 0.0507, all right? And so that would be the way to do it by hand. Now, there is an easier way to do it. And you're like, why didn't you tell me? Well, because some of you may have professors that want you to do it this way, okay? Now, it does turn out that if you go to data and the data analysis tool, at the bottom, there is a t-test, 2 sample, assuming unequal variances. That's what we had because our variances are not equal. They're very different. And so I click on OK. Variable for range 1, that's Death Storm right here. Variable 2, that's Firestorm right here. I do have labels. The hypothesized difference is 0 from my hypothesis test right here, right? And then I want to put the output for this next to my data over here so that we can see it, right? So I click on OK, and here you can see there are the means, here are the variances, right? Here are the observations, the hypothesized difference. Now you'll see the degree of freedom is 11, and that's because, again, they actually use the complex formula for calculating the exact degree of freedom, which is nice. They do it for you, so you get a little more accuracy. But there's our t-stat, right? Exact same value. And now we can see that our p is 0.043. So again, this p-value is a little bit higher. In fact, this would not be considered statistically significant, but this one is, right? Because it's less than 0.05. So we're right on the edge of statistical significance. If I actually change the degree of freedom here to 11, you see that you get exactly the same answer for the p-value. But we were using 7, our rule of thumb version, and so you've got this value right here. And so that's 2 ways of doing the hypothesis test for independent samples, and that makes me happy.